Okay. Okay, so as a reminder, when it beeps, that means that we want to come back together as a class and work together on the problem. So the first two classes, you guys were really good at not talking while I was trying to present things. On Friday's class, I know it was Friday afternoon, we had a little bit of problems with that. So we're going to try to, when it's time to talk, the timer is going, you can talk to the people around you. When the timer goes off, please pay attention up here so we can get through the content. So this question is about points, and that's what today's class is about. And so we're looking at things that look like this. So this is the Cartesian plane. And I've lost my pen somehow. OK, here it is. And we're talking about, in this problem, I said, let's look at the point -3, -3, 4. Where is this point? You go over -3, and then you go up 4. So it's this point right here, -3, 4. What quadrant is it in? It's in quadrant 2. Let's see how many people got it right. Quadrant 2, 80% of people got it right. Very good. And the next question says, draw a triangle and use Pythagoras. So what is the triangle I'm talking about? Here's one side. Here's the other side. It's a right triangle, and it has a hypotenuse that looks like this. So you have to know this side is length 3. This side is length 4. And to do Pythagoras, you're going to calculate the length of this hypotenuse. What is it? Well, the hypotenuse, let's call it d. D squared equals 3 squared plus 4 squared. That is what Pythagoras says. And it comes from the legs 3 and 4 of this triangle. So let's see if you guys got this right. What did people say for the next one? The answer is square root of 3 squared plus 4 squared. And can I go to this blank? What did people say? 0, 1, 2, 3, all the way up to, okay, lots of random answers. 45% of people got it right. This is the right answer. And if you put it in your calculator, 16 plus 9 is 25. The square root of 25 is 5. So if you actually calculate what this is, therefore, d equals the square root of 25 equals 5. That is the correct answer. So 45% of people got it right. Let's see. Some people did like half the steps. So this is nice, but you got to do the square root at the end. Also, there shouldn't be a squared here. So this, this is close, but not right. What else was there? 25. Again, you got to do the square root of 25. Again, yeah, this is good. Do the square root of this. What other things were there? Square root of 74. This person did the wrong problem, maybe. What other things? Some other people put in some guesses. All right. So I don't know what the issue is. Maybe people didn't have enough time. Any questions or comments about that one? Pythagoras. Okay, well, the next thing in the notes is writing down exactly what we did in a more complicated case. So we did the case where the origin is at 0, 0, and we're doing the distance from a point to the origin. In the notes, next up, we have the distance between 2 points. So here is the point x1, y1, and here is the point x2, y2. And we have a big triangle between these two things. You can divide up the two triangle sides into one thing I call delta y, which is y2 minus y1, and delta x, which is x2 minus x1. So you sort of have an amount of x change and an amount of y change. And we always do the second one minus the first one. So we're doing delta equals second point minus the first point. And that way, that's why we have x2 minus x1. So in this situation, x2 minus x1 is a positive number, y2 minus y1 is a positive number. They're both positive. And from this picture, you can see that d squared is related to delta x squared and delta y squared by Pythagoras. So this number d squared equals delta x squared plus delta y squared. That is Pythagoras for this big hypotenuse over here. And that is the next formula. So on the next page, they've written this down as a formula. They have this thing. The distance between 2 points, there's a formula for d, but it really comes from rearranging what we just have, Pythagoras. So this is delta x squared plus delta y squared, and you do the square root. OK. So now you know how to do it, even if one of the points isn't the origin, and you can calculate the distance between 2 points. Here's one, the point -3, 4, and the point 2 minus 3. So I will let you guys do this one. Try it on Mathematize. I'll give you 2 minutes to try it, and then we'll take it up. Okay, there's like 30 seconds left. Who's going to need more time? Put your hand up if you need more time. Just a few people. Okay, I'm going to add 30 more seconds. Okay, so let's take up and see how people did. All right. So yeah, some people had some good questions about the mathematized inputs. Sometimes when we do math questions, you can enter in a formula, and you can put in any crazy formula you want as long as it's equal to the right answer. Or you can put in decimals, and I think it says do it to 2 decimal places. Mathmatize will mark both of those as correct as long as you have the right number. And by putting in a formula, you can see what the formula is. By putting in decimals, you can practice using your calculator. So it is up to you how you want to do it on these ones. But let's see what people said. And I guess it also reveals the answer when we do it. What did people say? Blank one. Okay, one moment. I think it's loading. Okay, while it's loading, why don't we work on the problem? So the way I do these is you can think of d is going to be the square root of delta x squared plus delta y squared. And you can just write down what these are going to be. So delta x, the difference of the x values, 2 minus minus 3. Don't forget the second minus. And the delta of the y values, minus 3 minus 4 plus minus 3 minus 4 squared. So this is 2 minus minus 3 is 5 squared. Minus 3 minus 4 is technically negative 7 squared. If you leave off the minus sign, that's OK, because we're squaring it. In either case, you get the square root of 25 plus 49, which I think is the square root of 74, which was the answer somebody gave to the first question. So they probably did this question by accident. Let's see, did the answers load? OK, so I guess I've revealed what the right answer is. OK, so lots of guesses of numbers. Square root of 74, 85 people got that right. So if you typed in a decimal that was close to the square root of 74, you also got it right. Okay, so formulas like this, it will accept these as long as they're correct. Oh, all right. But this one, right, this one is wrong. So this one, the person did 2 and minus 3. Those are the coordinates for B, and minus 3 and 4, those are the coordinates for A. You have to mix them, right? You have to do the 2 minus the minus 3 and the minus 3 with the 4. So it's actually an instructive error to see written out. All right. Yeah, this one would have been correct if they didn't write equals 8.6. So they could have typed in 8.6, or they could have typed in this. But if you type in both, then that's something else that's not right. OK. This one, they forgot the square root. The square root sign needs to go over everything, right? The square root sign needs to go over everybody. And also, if you write negative 5 squared, that's negative 25. So if you want negative 5 all squared, you got to put the brackets around the negative 5. OK, so some good instructive wrong answers here that we can learn from. Any other questions or comments about this one? The distance between 2 points? It's all Pythagoras in disguise. So if you understand Pythagoras, you'll understand this one. OK, next up, we're going to see what happens. What happens if instead of 2 points, you have 3 points? And 2 things can happen when you have 3 points. Either the 3 points are all in a line. Can I ask people to stop talking? Thank you. So either the 3 points are all in a line, like this, and we call that collinear, or they're not in a line, and they make a little triangle like this. And the nice thing about points in a line or points not in a line, you can tell whether or not they're in a line or not just by looking at the lengths. So if you look at these 3 lengths, AC is this big length, AC, AC. And the other two lengths, AB, and BC, look like this. And depending on how they line up, you can figure out if they're collinear or not. So in this first example, the 3 points are exactly lined up so that AC is exactly AB plus BC. They're lined up like that. If you were going to start at A and you were going to do a trip all the way to C, that would be the same distance as doing a trip first to B and then doing B to C, right? That's what we're saying. The distance, AC, is the sum AB plus BC. On the other hand, if they're not collinear like this, and someone says, please do a trip from A to C, that's starting here and traveling like this, that is shorter than going from A to B and B to C, right? If you have to make a stop at location B that's going to take you slightly out of your way, you have to go a little bit longer. AC is shorter than, less than, AB plus BC. And you can use this to test if things are collinear or not. This is called the triangle inequality. Triangle inequality. And it's very useful all over the place. So that's this less than sign here. OK, don't underline it. Circle it. If you underline a less than sign to emphasize it, it changes the meaning. So don't do that. OK. So to see an example of this, here are 3 points, A, B, and C. I gave you their coordinates. And the question is, are they collinear? Are they collinear? That's what we're trying to do. And to do this, we're going to calculate these distances. So we're going to calculate AB, we're going to calculate BC, and we're going to calculate AC. All right? And again, this is a repeat of the question we just did. It's Pythagoras. You're doing the delta y's and the delta x's for these points over here. So I'm not going to spend too much time doing that. This is a repeat. You can try to do it your way. The distance from A to B, the delta x's are 1 minus 0. Actually, let me do it. Let me be consistent and do 0 minus 1. Let's always do the second one minus the first one. 0 minus 1 squared plus 3 minus 7 squared. OK, and if you do that right, it should be 1 squared plus 16 is the square root of 17. What about B to C? B to C, we do the square root. We do the delta y's minus, actually, let's do the x's first. Minus 2 minus 0 squared is the x's. The y's are minus 5 minus 3 all squared. And if you do this correctly, you should get the square root of 68. 4 plus 64. Did I do that right? Yeah, minus 5 minus 3, it gives an 8. And when you square it, you get 64. So you get 4 plus 64, which is the square root of 68. OK, what about the last one? The delta x is minus 2 minus 1. It's going to be 3. And the delta y is minus 5 minus 7. So this is 3 squared, which is 9, plus 12 squared, 144. So square root of 153. OK. And now that you've calculated these 3 distances, you can imagine drawing the triangle just like we had before. So you can draw the triangle A, B, C, and it's going to look something like this. Or it's going to look like this, A with B on the way, and then C like that. And you can tell which triangle it's going to be by comparing the lengths. So you're going to compare these numbers, and you're going to see, is it obeying the triangle inequality? Is it an equal sign? Is one the sum of the other two? Or is one strictly less than the other two? And so you're going to figure out if they're in order or not. And I'll give you one more hint, actually, which is, here's the hint. 68 is actually 4 times 17. So this is the square root of 4 times 17. So let me squeeze that little hint in there. And 153 is actually 9 times 17. So this is the square root of 9 times 17. And that little hint might help you figure out by some algebra whether or not the sum of these two is equal to the other one or not, and answer the question, are they collinear? But either way, you guys are going to do the problem in Math1030. So take a look at this. Use what we've calculated so far as a starting point. And then let me know, are they collinear? Yes or no? And here's what we have so far. Okay, 30 seconds left. If you're stuck, you can always take a guess, 50% chance. Okay, let's see. What did people say? Is there going to be a consensus, or will people be confused? Okay, 88 to 54. That's not, pretty close to 50-50. 50-50 would be 70 votes in each, and we have 54 to 88. So let's take a look at this in a little more detail and see, was the majority right or wrong? And this is a classical case of having a left-hand side and a right-hand side. So the left-hand side is AC. The right-hand side is this sum. The right-hand side is the sum BC plus AC. Or do I want it the other way? I think I wanted AC is the longest one. AC is definitely the biggest one. So AC is on its own, which means the other two sides are AB and BC. So I didn't quite get that right. Let's fix that. AB plus BC. And we have to compare these two things, right? We have a left-hand side and a right-hand side. And we just got to see, are they the same? And this is where your high school algebra comes into play. You can simplify these two things, and then you can compare them. If you have two numbers and they're not really simplified, they're written in crazy ways, they're hard to compare. But if they're simplified, it's better. So let's start with AC, which is the square root of 9 times 17. That was the hint. And by the high school algebra, you can factor a square root out. You 9 and 17, and you can do the square root individually. So square roots go in and out of multiplication. That's one of the videos. And the square root of 9 is 3. That one I know. So I have 3 times the square root of 17 on this side. Okay, what about the other side? The other side, I have AB and BC. AB, we said, is just square root of 17. BC is the square root of 4 times 17. 4 times 17. And again, I can factor the 4 out. Square root of 4 times square root of 17. Square roots go in and out of multiplication. And the square root of 4 is a number I know. That one is 2 times the square root of 17. Okay, last step, factoring. There's a square root of 17 in both terms. So if you factor them, you get 1 copy of square root of 17 plus 2 copies of square root of 17. And 1 plus 2 is 3. So the left-hand side, we simplified it down to 3 times the square root of 17. The right-hand side, we simplified it also down to 3 times the square root of 17. These two things are equal, so equal. So check mark, equal, equal. And if they're equal, that means we are in this picture where there's an equal sign. And if we're in that picture, they're collinear. So the correct answer is they are collinear. 63% of people got it right. So are there any questions or comments about the method or the algebra? If you haven't studied for the algebra quiz, this might look like alien to you. But this is all stuff, the square roots, factoring, those are all the things that are tested on your high school algebra quiz. Questions or comments? Okay. Of course, the other thing you could have done, you could have put them in your calculator and gotten a number and then seen what the number is and then compared the numbers. That will sometimes work. In this problem, it would have worked just fine. In other problems, maybe that have some x's and things, it wouldn't work. So you need to be able to do it both ways, maybe with a calculator or without. All right. We're going to move on to the next thing, which is midpoints. Midpoints. And so this is a kind of geometrical picture. You have 2 points. Here's the point x1, y1. Okay. I'm going to politely ask everybody to quiet down so I can present this stuff. Some students asked me last class if I could remind the class to not talk while I'm presenting. Thank you. So there's 2 points, x1, y1, and the other point, x2, y2. And we want to know, where is their midpoint? There's some point in the middle that is kind of equally spaced between them, right? An equal spacing between x1, y1, and x2, y2. And here is the formula. The x-coordinate is x1 plus x2 divided by 2. That is the average of the x's. And what about the y's? The y's is y1 plus y2 divided by 2. That's the average of the y's. So you're used to, when you have numbers, how to average them. The midpoint is, in some sense, the average of two two-dimensional points. And its coordinates are exactly the averages of the x and the y coordinates. So here's an example. If you have the point minus 3, 3, and 1, 5, what is the average of the x's? Well, the x's are minus 3 plus 1 divided by 2. So minus 2 divided by 2 minus 1. And the average of the y's is 3 plus 5 divided by 2, which is 4. So the coordinates of the midpoint are negative 1, comma 4. All right, very nice problem. You can make sure that, sanity check, make sure it's correct. Let's draw a picture. And of course, the best way to draw a picture of math is to use Desmos. So what are the points in this problem? The one point on the left was negative 3, 3. And the other point was 1, comma 5. So those are our 2 points. And now we can see, where do we expect the midpoint to be? Well, somewhere in between, right? Maybe actually right exactly here, right? And then it's 2 over 1 up. It's like a knight move in chess away from the red point and the blue point. We calculated that it was negative 1, comma 4, which, look at that, is exactly in between. So we got it just right. There you go. Pictures, midpoints. That is the midpoint rule. Last but not least, in our little exploration of two-dimensional points and what can you do, is the idea of slope. And I will give you a little warning. I will give you a warning. Slope is important for calculus. Slope. So if you're going to forget 2 out of 3 of these topics today and remember one, the one you should remember is slope. That's the most important one because it comes up in calculus. What is slope? If we go back to the picture we had on the second page today, we had a delta y and a delta x, and we talked about the distance, Pythagoras with delta x and delta y. The other thing you can do is the ratio, delta y over delta x. So the slope, let's do it down here. The slope is delta y over delta x, the slope of this line. It is related, if you have an angle theta here, this is the same as the tangent of theta. So tangents are slopes. The tangent of the angle is the opposite over the adjacent. The slope is also the opposite over the adjacent. It's the y's divided by the x's. And to see it in action, let's do a quick example. Two little remarks. Watch out for horizontal lines. Horizontal lines have a slope of 0. And vertical lines have slope equals infinity, in quotes. Why do they have a slope equals infinity? Because you have a divide by 0. If the delta x, you have 2 different points, and the delta x is 0, then you have no slope. So watch out, vertical lines don't really have a slope. Horizontal lines have slope 0. So let's do an example. Here's the example. Part A, we have 2 points, negative 1, 2, and 3, 10. We can calculate the delta y and the delta x. As we have been, the delta y is 10 minus 2, which is 8. And the delta x, 3 minus minus 1. Just watch out for those minus signs. 3 minus minus 1 is 4. So what is the slope? The slope is delta y over delta x, 8 divided by 4, which is 2. The nice thing about the slope is it automatically tells you kind of what this thing looks like, right? So it looks something like this. There's a picture like this. So the first point is somewhere over here. The second point is somewhere over here. And you can kind of draw a triangle. You can draw a little slopey triangle like this and say every time you go over 1 unit, you go up 2 units. So it's a over 1, up 2 triangle that fits in this situation. The fact that it's positive tells you that it's increasing from left to right. So increasing, so slope positive, that means it's increasing from left to right. You can get all these facts just by the number we calculated. Later on in calculus, we're going to see that there's a way to calculate these kinds of information about increasing and decreasing, what the picture looks like, all using these methods that we're going to learn in calculus, calculus methods. So we're going to get way more fancy on slope. Right now, this is like slope 101. So to see if you guys are getting slope 101, you guys do part B. You guys do part B. Part B has 2 other points. So do the slope of those 2 points. Okay, so I closed the QR code by accident. If you need to access Mathematize, you can use this 4-letter code, SWRL today. Okay, there's like 10 seconds left. Put in your answers. Okay, let's see what do people say. A lot of people are putting their answer in at the last second. But put up your hand if you just put in a guess because you ran out of time. Okay, lots of people. I think only a couple people put in a guess. So maybe it's okay then. Let's see, what did people say? Close this. Okay, and it's a little laggy today. So maybe we'll get started while we're waiting. Oh, okay. Okay, again, we got all the numbers 0, 1, 2, 3, 4, 5, 6, 34, 696,969. That is incorrect. Negative 3/4 is popular. This person found the distance between the points. Remember, we're asking for the slope here. So let's see. No, negative 4/3, that's related to negative 3/4. Negative 3/4 was by far the most popular, and that is the right answer. So if you put in negative 3/4, good for you. Let's see how you do it. So again, delta y and delta x, I think is the easiest way to calculate it. So the slope is the ratio. What were the 2 points? Negative 3, 8, and 1, 5. So the delta y is 5 minus what? Let's make sure we copy it down correctly. 5 minus 8. And the delta x is 1 minus minus 3. So you get negative 3 divided by 4. There you go. Negative 3 divided by 4. That's the slope. This means that if you were going to draw a picture of this situation, it would be going down, but not down very steeply. So it would look something like this. For every 3 units you go down, you go over 4 units. So down, also known as decreasing. And we kind of know by how much. Okay. So like I said, slope is important. We're doing it slowly now because we're going to be doing slope on steroids when we get to calculus. I think that's a good expression for what calculus is. It's using slope on things that are not lines. How do you find the slope of something curvy? That's what calculus is. If you don't even know the slope of a straight line, you're going to struggle. Any questions or comments about slope or this problem? So I'm not quite sure what the other 34% of people were doing. Maybe they just made a mistake, a small mistake. Maybe they didn't understand what was going on. Do feel free to ask me if you're not understanding. All right, there's one more activity we're going to do, which is using slope to answer the same question we did before. So a few minutes ago, we calculated these 3 points, A, B, and C. We said, are they in a straight line or not? And we did it using distance. So that was method 1. Method 1. That was triangle inequality, and distance. Right? So we checked, is the distance AC, is that the same as the sum AB plus BC? Is going all the way from A to C the same distance as going to A to B and then B to C? If it is, they must all be in a straight line. How do we do it with slope? Method 2. Method number 2, use slopes. Okay, so we're going to do it somehow with slopes. What is the method going to be? I think this is a good one. I could just tell you what it is, but I think if you stare at this for a little bit and imagine where are the slopes in this problem, you can come up with what it is. So I'm going to give you guys like 2 minutes to just chat with your neighbors if you want, or just think about it. How would you use slope to tell if the points are collinear or not? Of course, we already know the answer here, but pretend you didn't know the answer. How would you use slope to calculate? So take 2 minutes, think, and then we'll have some discussion about what the answer is. Okay, so 10 seconds left, and then we'll come back together and discuss. Okay, so you had a few minutes to think about it. Unfortunately, I can't have you, there's no way in Mathematize to have like a paragraph answer, right? It's got to be a word or not. I think explaining how method 2, using slopes to tell if they're collinear, takes more than one word, but not a lot more. Does anyone have an idea they want to share about how would you use slopes to tell if three things are in a line or not? Yeah. Okay. Find the slope of AC, and then what? Okay, so you check the slopes of two different segments, and you see if they match or not. So I like this idea. So if you said AC, which would be like, find the slope of this little triangle over here, and then you said AB, which would be like this little green triangle in here, right? And if the green triangle and the red triangle, they're two different triangles, but if they have the same slope, like if they have the same rise to run ratio, and they match into each other, then you know that the two line segments from A to C and A to B kind of match together as well. And you can kind of see that visually on the picture. And this works for any two segments. So the student's suggestion was AC and AB, but you could do AB and BC, you could do any of them. So as long as they share a point in common, if they have a point in common and they have the same exact slopes, they have to line up perfectly. So this is a perfectly good idea. So check slopes for two line segments, and if they match, then collinear. And if they don't match, you know for sure it's not collinear. So for example, if they don't match, it might look like this. If it's a bent angle, then the slopes won't match. So all you got to do is calculate two slopes. Let's do the two that were suggested. The slope of AC and the slope of AB. Sometimes people use the letter m for slope. That's the same m as an mx plus b. I don't know why we chose m, but we did. The slope of AC, I have 7 minus 5 divided by 1 minus 2, which is 12 divided by 3. So a rise of 12 units from A to C vertically and 3 units horizontally. That is 4. And from A to B, it's 7 minus 3 divided by 1 minus 0, which is 4 divided by 1, which is also 4. So because these match, therefore, they are collinear. So that's another way to do the same problem. You can either do it by distance or by slope. If you take linear algebra class, you will learn yet another way to do it. Turns out lines are important in math. Any questions or comments? OK, we're going to stop there. Next class, we're going to start in chapter 5.